Okay, everybody, thanks for hanging out here over your lunchtime to listen to me. My name is Stephen Clarke. I'm a usability engineer with the Visual Studio Usability Group, and I'm going to talk to you about API usability. I'm going to start out by describing what API usability is, and then I'll talk about why you should care, why it's important that the APIs that you're designing and the APIs that you're building are as usable as they can possibly be. I'll talk about some of the techniques that you can use to ensure that you're designing usable APIs. And in particular, I'll be talking about the framework that the usability group in Visual Studio uses to describe API usability results. And I'll talk about how you can use that framework to think about API usability and also to think about the usability requirements of your customers who are going to be using your API. I'll talk about ways in which you can gather customer feedback on your API so that you can, at regular points along the project lifecycle, you can stop and take stock and measure whether or not you are going to achieve your goal of delivering a usable API. And then lastly, I'm going to talk about some common problems that we've observed in the usability labs while doing API usability studies. To begin with, many people, when they start thinking about API usability, they assume that what that means is an API that people can be successful with. So imagine an API for file I/O. The assumption is that a usable file I/O API is one that users can pick up and build applications that write lines of text to a file, or that they can use this file I/O API to build applications that read lines of text from a file. And if they can do that successfully, well then, yeah, the API is usable. That's fine, we're good to go. Enabling success in your API is the absolute minimum bar that you should set for yourself if your goal is to deliver a usable API. If you miss that bar, anything less than that bar, then by definition, your API is completely unusable because your developers, your customers, will not be able to use that API to accomplish the scenarios that you've designed the API for. You can go one step beyond enabling success. As well as making sure that your developers can be successful, you can also make sure that as they're working, they understand what they're doing. In other words, there's no magic attached to your API. There's no mystery about how it does what it does. Many times, people come into the lab and tell us, you know, well, fine, I can make that code do what it needs to do, but I have no idea how that works. Something's going on there, there's a bit of magic, and I don't understand it. You don't want to be in that position. You want to make sure that your developers, your customers, are able to understand what they're doing while they're using your API. You can go even one step beyond that, though. As well as enabling users to be successful, as well as allowing them to understand what they're doing as they're doing it, you can also enable them to predict how to use the API. They can look at the public interface of your API, and based on that interface, they can determine what that API does. They can determine how to use the API. They can look at sample code written against the API, and they can understand what that code does. They don't have to read reams and reams of documentation and books and what have you, just to be able to get to grips with your API. The API itself is almost self-documenting. So when you're aiming to deliver a usable API, don't just be satisfied with enabling success. Make sure that people can also be, as well as being successful, they can also understand what they're doing and they can predict what they need to do with your API. So if you're going to do more than just enable success when you're designing and implementing your API, that sort of means that there's more work involved. If you were just aiming for, well, let's make sure people are successful, that's much less work. So why should you go to all that extra length of doing that work? Why should you care? Well, one of the main reasons for it is that by delivering a usable API, your developers using your API, your customers, will be much more productive with the API. Instead of spending all their time figuring out how your API works and how to use your API to do something useful, they can spend time focusing on their application. They spend time focusing on achieving their business objectives, their requirements. We have many people come into the labs and we ask them to work on API studies, and one of the things that they often tell us is, you know what, I've got a job to do. If you're going to force me to read all this documentation, if I have to take a week-long class to learn your API, forget it. I'm not going to touch it. People want to be productive. That's the benefit of APIs. But if you force them to do a whole load of learning, they're not going to touch it. Another reason for caring about usability, for making sure your API is as usable as it can be, is that developers using a usable API are much less likely to make errors when they're using the API. And there's two reasons for that. First of all, if they can understand what's going on, they understand the types of things that might go wrong, and they'll do their best to avoid that. Secondly, if your API is not usable, if it's really difficult to use, people are they don't like doing difficult things. They'll look to take shortcuts. And sometimes those shortcuts might come back and harm them. They might cause damage to their application, further on down the road after they've taken that shortcut. And then once they get into that position, it's very difficult to work out, well, what's the reason for the behavior I'm seeing in my application? So if your API is usable, you're going to help reduce the number of errors that developers will make. If the API fits in the context of some framework, such as the .NET frameworks or WinFX, then if usability is applied across the board of that framework, then you gain benefits from being able to learn one part of the framework and then apply what you've learned in that part of the framework to some other part of the framework. There's not the silos of APIs all over the framework that all behave and work differently. They're consistent. And so it makes it much easier for somebody to adapt to and use the whole framework. So those are all good user benefits from delivering a usable API. What are the benefits for you? Well, if you're taking the time to understand what your users are doing and how they're working and how they think, you can use that information to help you make better design decisions as you proceed through your project. It's inevitable that you will have design decisions that need to be made. Should we implement class foo, or should we call the class foo, or should we call it bar? Who knows? Many times those decisions are made by the person in your group who has the loudest voice and keeps on saying it should be foo, it should be foo, it should be foo. That ends up being what happens. But if you have user data, if you understand your users, you can quickly make a decision based on what users want. If users all clamor for something called bar, then you give them bar. You've made a nice, easy decision, and it's based on user data. Fundamentally, API usability is about understanding what users do, understanding how they think, and applying that understanding to the design of your API. It's all about figuring out what's the right thing to do. The design guidelines that you're learning about in this class will tell you how to design the thing right. Usability is all about figuring out what's the right thing to do. So given that you care about usability, you want to make sure that your API is as usable as it can possibly be, how do you go about doing that? Well, the first thing to take note of is that usability is not something that can be tacked on to the end of the project lifecycle like a wee check mark. Say, did we do usability? Check, yep, now we're ready to ship. If you wait until you're ready to ship to find out if you're shipping the right thing, it's far too late. What are you going to do if you discover that, oh, that's amazing, we actually did a study with users and this, you know what, they all want foo, and we gave them bar. It's too late. They're going to be stuck with what you've designed. You need to pay attention to usability right from the start of your project. So that's all well and good saying, yeah, pay attention right from the start, but what does that mean? What do you have to pay attention to? This is where the Cognitive Dimensions framework comes in. The Cognitive Dimensions framework describes 12 different aspects of an API that together help define what it means for an API to be usable. So with these 12 aspects, with thinking about these 12 different dimensions, you pay attention to those as you proceed. And I'll talk in more detail in the next slide, in the next few slides, about what that actually means. But with that framework in mind, you have something tangible with which you can pay attention to throughout the life cycle of your project. So that's good for understanding APIs and how they can be determined to be usable or not. But APIs aren't used in isolation. They're used by users, by developers. And you have to know how those developers work and how they think in order to make sure that you're doing the right thing for them. And I don't just mean that you have to know that your your developer's named Bob. He works in the IT department of the local insurance company, and he likes to eat broccoli for lunch. That's not enough. What I mean is you have to know, how does your developer, how does your customer work? How do they think? How do they behave? And again, the Cognitive Dimensions framework can be used to help here. It can be used to describe the requirements that a user has when they are working with an API. And again, I'll talk in more detail about that in the next slide. So now we understand how to talk about the usability of an API. Now understand how to talk about the usability requirements that your users have when they're using an API. But that's still not enough. You need to know the scenarios in which they're working. You need to know what are they going to be trying to doing with this API. What are the core tasks that we need to support? You need to take that information and make sure that the classes that you implement, that you expose, the method names, the property names, etc., map on and are a good fit to the scenarios that the users you know all about are working with. So armed with that information, you could do a pretty good job at delivering a usable API. But it's really important to stop at regular points along the way and just take measurements. Make sure that you are going to achieve your goal. And you do that through gathering user feedback. And do it early and often. Do it as early as you can and as often as you can. Usability studies are one great way of getting that customer feedback. But there are other ways, which I'll talk about, that you can get customer feedback without going to the expense of recruiting people to come into the lab and running studies that take a week long. You can do much cheaper you can use much cheaper techniques of gathering customer feedback. So I've talked a bit about the cognitive dimensions framework. So let me go into a bit of detail about what this framework is. First of all, the framework is not something that we in the usability group in Visual Studio just made up and pulled out of the air. It's actually based on 3 decades worth of research, mainly done by University of Cambridge in the UK. There's a group there that for the last 3-4 decades have been doing programming language usability research. And have done a lot of work into determining what's the best way to represent conditional. And through their work, they have come up with the cognitive dimensions framework to describe programming language usability. What we've done here at Microsoft is adapted it for API usability. So I'm just telling you this just in case you go out after the class and look up the cognitive dimensions online. You may find something slightly different. The reason for that is programming languages and APIs, while they're similar, they're obviously different. And so we've adapted the framework to some extent to make it more applicable when we're talking about API usability. So that's a bit about the background, about where the framework came from. Gives you a sense of the validity and the nature of that framework. But we can use the framework, as I've said, to talk about the usability aspects of an API and the requirements of a developer. Now, the framework is just here on the right-hand side. You can see the 12 different dimensions. I'm going to talk to some extent about some of those dimensions in more detail. But in one sense, one of the greatest benefits of this framework is that it gives you this vocabulary. It gives you a way to talk about aspects of an API that determine its usability, which means that if you're in one group, if you're, say, working in Windows Media Player, you're working on an API there, and you come up with some problem to do with progressive evaluation, you can talk to somebody in the Avalon group, and they'll know what you're talking about. Oh, we've seen that problem. We had a progressive evaluation problem in our API as well. What we did was blah, blah, blah. This is how we fixed it. So you have common vocabulary to talk about common problems. Provides a mean to talk about an API from an end user perspective. There's nothing in here about actual sort of the API itself. It's all about how users work with the API. And so even just using this vocabulary, immediately you're talking about users. You're thinking about how users are working with your API. Now, while it's based on research done by the University of Cambridge in the psychology department, a bunch of psychologists and academics worked on this framework, it is absolutely not designed such that you need to have a PhD or any training in psychology to use the framework. The main aim was to produce a simple and effective framework that practitioners, such as ourselves, could use when designing APIs. I'll have a link down here that you can look up for more details on the particular framework, and there's some useful information there about more detail about individual dimensions in the framework. But let me take over the next 2 slides. I'm going to talk about how you can use the framework to describe an API and how you can use it to talk about users and their requirements for an API. Now, I don't have time to go into detail on every dimension, but I'm just going to pick out half a dozen or so and talk about what they mean with respect to API usability and your user requirements. The first dimension we're going to look at is called abstraction level. This is basically a measure of the type of abstraction that your API exposes. And we go we talk about a scale of, does the API expose a bunch of primitives, or does it expose an aggregate? Or does it expose something in between, such as a factored component? You can imagine a file I/O API exposing a bunch of primitive components where you do file I/O by manipulating some byte array, let's say. You represent a file as an array of bytes. You peek and poke, you do some memory manipulation. That's how you read from the file. You can imagine an aggregate component where you just have a class that represents a file. And you can read from a file, you can write to a file, you can create files, you can move files, copy files. You can do everything you want with a file with this one class. It's an aggregate of all the tasks, all the scenarios that you can do on a file. In between, you'd have a factored component where you factor out all those tasks and you separate them into separate classes. Similar to what we have today in System I/O, we have stream writer, we have stream reader. Those are factored components that factor out the different tasks. You use a stream writer for writing, but you use a stream reader for reading. And there are benefits to different, whether you expose primitives or aggregates or factored components, but those benefits only make sense depending on the users that you're working with, and I'll talk about that in the next slide. The learning style dimension talks about how can the API be learned? Can somebody just learn about it from the bottom up? They learn about one class in the API, they get going with that, and then they can add on top. They can incrementally learn about the API as they go along. Or do they have to come at it top down effectively and learn about the whole architecture of the API, get that 10,000 foot view before they can do anything successful with it? One example of learning from bottom up might be WinForms. You can drag a button onto a form, and you can start hooking up event handlers on that button. You don't really have to know the message routing architecture of how events get actually processed, get handed to that button. You can just start going. You can learn incrementally about WinForms. You can compare that to, for example, a framework such as MFC, where you do have to know the difference between how messages get routed to different components on your form. You have to know the difference between your document and your view and how those fit together. So you can't just learn about MFC from the bottom up. You have to come at it from a more top-down point of view. The third dimension we're going to talk about, working framework. This sort of gets to the cognitive load that you're placing on a developer when they use your API. It's the equivalent of working set. It's the mental working set of your API. How many DLLs effectively are you having to make the user load into their memory in order to be able to use your API effectively? Many times we require developers to think about a whole load of stuff as they're using the API that we don't represent in the API. That load can become overwhelming and cause people to make mistakes. Some developers are better at handling that than others, and you need to be aware of how your users will approach the API and what they'll expect it to do for them and what they'll expect to have to keep track of as they're working. Following on from that is something that we call work step unit, which describes the amount of work that a developer has to do to complete a given task. This isn't simply a count of the number of lines of code that they have to write to accomplish a task. There could be 2 lines of code that the developer has to write, but they could still think that's an awful lot of work because I've got to think about these 2 objects I'm creating. I need to make sure that I do one before the other. There's a whole load of stuff I need to think about. The work step unit could be considered too large, even for something that looks as small as 2 lines of code. Similarly, you could have something that's 10 lines of code, but the developer thinks, no, that makes sense. It maps onto what I think I need to do. And so I can see what I need to do right there and then. It makes perfect sense. Premature commitment is an interesting dimension to think about. There are many times in APIs that we force developers to make decisions about how they're going to use an API. Imagine or you don't have to imagine, there's good examples in some complex UI layout APIs that allow you to create different kinds of panels, that there are dock panels and flow panels and all sorts of layout mechanisms that a developer can use. Many times people come up and they start working with these panels and they'll make a decision early on to, okay, I'll use a dock panel. I'll start docking my controls all around the form here. I'll put this one at the top, that one at the bottom, this to the left, that to the right. I'll fill the rest of the space with this control. Suddenly there's a change in requirements comes along. You know what, you need to add 2 buttons in between the top and the bottom here. But because of the way they set their form up, because they chose to use a dock panel early on, it can be very difficult to make that change in their layout. So they were prematurely committed to using this dock panel, to using this layout scheme. if they're not aware of the impact of making decisions such as that early on and what it will do for the rest of their API, for the rest of their application, they can get into serious difficulties in making changes to the application, which are inevitable as people are building apps. Following on from premature commitment is progressive evaluation. If there's a lot of work you need to do, if there are decisions you need to make about the work you're doing, to what extent can a developer stop halfway through and say, is this the right thing to do? Is this the right method I should be calling? Is this the right class I should be using? Progressive evaluation isn't just about being able to stop, compile, and run your application. There's elements of what the documentation can provide in telling you this is the right thing to do or not. There's elements of what the names of classes are that can communicate to the user whether or not they're doing the right thing. If we look at these same dimensions and apply them to how users think, we can see at an abstraction level, different developers prefer to use different types of components. This is where it's really important to know who your users are. Some developers really love aggregate components, and they just love being able to explore how an API works. They can create an instance of an aggregate, then they use tools such as IntelliSense from within Visual Studio to explore and see what they can do on that component. If those types of developers who like the exploratory programming approach, if they are given a set of primitives, they can't explore so easily. They can't use IntelliSense because all IntelliSense will tell them is what they can do on one type. But with a set of primitives, it's more likely they're going to have to use those, combine them in lots of different ways. And it can be difficult to explore and discover that. On the flip side of that, there are some developers who believe that there's no way that an API can expose the power and the flexibility that they require. That the only way that they can achieve that power and flexibility is if the API gives them a set of primitives that they can then combine in lots of weird and wonderful ways to achieve their objectives. So there are absolute, definite preferences by different types of users for different types of abstractions that your API exposes. Different developers have different learning styles. Some developers like to just learn by doing. They don't want to take the time to read a ton of books or a ton of documentation. As they're coding against your API, they'll keep track of what they're doing, they'll remember what they're doing, and they'll build up an understanding of your API incrementally. Other developers like to be able to step back for a second, or for a couple of hours, or for a day, or however long it takes, to understand the overall architecture of the API, just to get a general feel for what the API does. Part of it is because they want to make sure they don't reinvent the wheel. They don't start implementing some class that you've already implemented for them. Part of it is so that they don't make mistakes. They're looking ahead. They're planning ahead and making sure, I see how this API works. If I do this, this will cause me not to be able to do this later on. So I want to make sure I don't do that. So they take that time to think ahead in advance how the API works and how they're going to use it. Working framework, that's the sort of mental working set. Different developers have a different sort of memory capacity, if you like, to put it into machine terms. Many developers think in terms of like a local scope. They're thinking they have a class that they're working with. There's a method that they're writing on that class. They'll be able to think about, they'll want to think about anything that goes on in that method. But they won't be so interested in or motivated to think outside of that, to think in terms of the whole application or even the whole system. Other developers are the exact opposite. They're almost paranoid. They're sure that there's something in the system where my application is running that's going to kill my app. Nothing to do with my app. I need to know the execution context in which my app is running. What's happening on the runtime? When's garbage collection kicking in? How can I control that? I'm scared that that will do something wrong with my app. So they have a much wider scope. And if your API if you're designing APIs for those kinds of developers and you don't expose that sort of information that they require, they're not going to trust your API. They're not going to feel comfortable working with it. Work step unit, for some developers, they like to work incrementally, line by line. Just write one line of code, get that done, they hit return, boom, right on to the next line. Literally, they work line by line. Other developers are much more comfortable working using primitive or factored components, let's say, that they need to use in combination with one another. You'll see in Visual Studio, we have in the Visual Basic Editor, we do the blue squiggly underline. That's helping developers who have that sort of incremental work step unit where they want feedback line by line. As soon as they hit return, they get a blue squiggly, tells them there's a syntax error, great, they can fix it. And that's the way they work. That feature really suits them. Developers that work with a bigger scale, with parallel components in combination with one another, that can often be frustrating because sometimes they're writing a bunch of code which is referencing some class which they haven't yet created an instance of. That's later on in their code they're going to do something. They start seeing blue squigglies all over the place. It's like, yeah, I know there's a problem here. I'm going to fix that in a minute. Just let me go on with my job. That sort of feedback can be frustrating and annoying for those types of developers. You need to make sure you know who your customer is and that you know how that they work so that you support that in your API. Premature commitment is one of there's some dimensions that they're either good or they're bad. You don't want to force developers to make a ton of decisions about how they're using their API, which later on down the road could come back and bite them. There's not very many developers who like having to sit down and make lots of decisions that they're stuck with. Most people like to be able to explore and make changes to their API, to the code written against an API as they work. And then lastly, progressive evaluation talks about that feedback. I've talked about how the VB editor gives you the feedback line by line. People like that or they don't. You have to know who your users are and what kind of feedback to give them as they work with your API. So understanding how developers work, describing it in terms of the cognitive dimensions, and then understanding an API and describing it in terms of the cognitive dimensions means you can do some interesting things. If you gather data, you can do a usability study or an API review or some other kind of way to gather customer feedback, and I'll talk about that in the next slide. You can compare the data you get from those studies with the data you know about how your users work. And if you have we have a tool in the usability group, a graphing tool, which allows us to do a comparison. This blue line that you see here is a profile of the opportunistic developer. And it's a profile in terms of every dimension in the cognitive dimensions framework. Each spoke on this wheel represents one dimension. So abstraction level is represented here. We have a value right out the edge, which refers to aggregate components. The values in the center, which refer to primitives. So right here on the edge, we're saying that the opportunistic developer likes components that are aggregates. For learning style, we're saying that on number 2, the dimension, the opportunistic developer likes to be able to learn from the bottom up. That value in the center is the bottom up dimension, the bottom up value. The value on the edge of the wheel is the top down. So for every dimension, we have a profile for that developer, and so we can graph it out on this wheel. Then we can do a usability study or gather feedback in some way. And we can look at the results that we get from that study, and we can describe them in terms of the cognitive dimensions. So we can look at the study, we can get feedback on it, and we can figure out that this API exposes a collection of factored components. And so we would place our API evaluation here somewhere in the middle of that spoke, where the factored components might lie. The learning style is top-down. There's no way somebody can learn this API bottom-up. And so we can proceed through the wheel here, and then you can get a comparison, and very quickly you can see that this API team were designing an API for Mort, and there's no way they hit the mark. They're way out on almost every single dimension. They're way out. They're not meeting the opportunistic developers' requirements. So how do you get that data? When should you get that data? When should you do that sort of comparison? Well, you should do it as early as you can in the process and as often as you can. Now, that doesn't mean that you have to run usability studies in the labs every single week. There are many different ways that you can gather customer feedback about your API. There's an API review where you can review code samples and headers. There's an experience review where your team can do some app building and spend a week working with the API, building apps, and then gather feedback based on those experiences. Or there's the usability study where you get customers into the labs, ask them to do a set of tasks, and get feedback that way. Now, there's just 3 examples of how to gather customer feedback. It's not an exhaustive list. There's many other ways you can gather feedback. One thing on the usability studies, you don't need to wait until an API is completely implemented before you can run a study on it. In fact, next week we're running a study on one of the WinFX APIs where all we have is a public interface. It's not been implemented yet, but we're going to run the study and see how the developers use that API to write applications. So don't wait. You don't have to wait until your API is implemented. You could do an API review before you've written a line of code. All you need is a piece of paper and a pen and write out, here's what the API looks like. You can review that. What I'm trying to get at here is there's really no excuse for not getting customer feedback. There are many things you can do here. In fact, I think the only excuse I could think of for not getting customer feedback is if you don't have customers. And if you don't have customers, you've got some other problems you need to sort out. So the usability is not going to help there. Get customer feedback as early and as often as you possibly can. I'll just spend a couple of minutes talking about the ways in which you can use these different techniques to get customer feedback. An API review, you will write code samples for the core scenarios that the API is designed for. And you'll review those code samples from the perspective both of reading the code and understanding what it does, but also writing the code. How likely is it that knowing what you know about your users, look at the code sample and say how likely is it they'll write that code. Then you can also look at it and say how likely is it that when they read it, they'll understand it. And you can get feedback based on those code samples. And like I said, you don't need to have anything implemented at that point. This is the very first thing you should do, probably. Is right, here's the scenarios we're targeting. Here's the code samples we want developers to write. Is this a reasonable thing to do? You can review the headers of your API for every class. Here's the public interface for that class. And look for, if somebody was browsing this API, would they understand what this class does? Would they understand what this method does? Does this parameter name make sense? As I said, you can do this before a line of code has been implemented, and you'll capture surface and obvious issues, which is great. Early on in the process, you want to make sure you're not doing something that's obviously wrong. The subtle usability issues about difficulties in using the interaction between components might be more difficult to capture, and discrepancies in how users think about the API and how the assumptions you've made about the particular programming model, those discrepancies will be much less likely to surface because it's your team that are more likely doing the review. So you can do another thing you can do is an experience review. You can set aside some time, whether it's a day, 2 days, a week, to use the API and build applications against that API. At the end of that period, however long it is, you can perform a structured interview with the team that built the applications. For every dimension, there's a set of questions that you can ask that get feedback based on those dimensions. And again, I have some more details about the particular questions you can ask on this site here, this blog, that has for every dimension here, it gives you a list of questions you can ask developers who've used your API to get feedback for every dimension. Now this works best, doing an experience review like this works best when developers have the same characteristics as your users. If you don't, if the people working on this experience review are different to your users, you're going to get different feedback, and it may not map onto what your users would actually say about the API. But it's a good way of gathering long-term data. Sometimes problems with an API can occur the first hour it's used. It doesn't make sense in the first hour. But after that, you get over that hurdle, then it makes sense over the long term. And this is a good way of getting that long-term data. You have less control over particular areas of API that you want to get feedback on because the team could be building one whole application that spans multiple areas of API, and there might be some specific feedback that you want that might be more difficult to get. It could also be expensive as well if you're asking your team to take a week out of their schedule to do this, but the benefits might outweigh the expense. A usability study can be useful for getting really focused feedback on a particular part of the API. If you have a design decision that you're trying to make, should we expose class foo or should we expose class bar? You can design a usability study and design a number of tasks that get good feedback to help you answer that question. So you need to understand what are the kinds of questions we want to answer. You recruit representative users. You can work with your usability engineer, your team, to help you figure out what the tasks will be, who the users will be, and they can help recruit those. Now, this can often be cheaper than an experience review because your whole team is not taking a whole week out of their schedule to take part and then to provide feedback. And as I said, it can be performed before the API is completely implemented. As we're doing next week, we have a public interface, nothing's been implemented, but we're going to run a study on that and see how well people can use that to write applications, write code against that API. An API usability study is one of the best ways to uncover subtle issues things that you'd never thought about, things that you took for granted or you didn't think people would have problems with. It's amazing just how quickly they can surface in a usability study. Another great benefit of doing such a study is that you get to watch real people do work. And that can be just as enlightening as anything. It helps you understand and it helps you empathize with the users. It makes it much easier in the longer term for you to make design decisions based on how people work, because you've actually got first-hand experience watching them work. You know how they're going to work. You know how to build an API to support their work patterns. So if you're interested in doing a usability study, what's involved? First of all, you have to be prepared. And you have to be prepared for receiving negative feedback about your API. Many times it can be a humbling experience. You're sitting behind that one-way mirror watching people use your API and they're not doing what you thought they would do. And immediately it's like, well, the user's stupid. It's not my fault, it's their fault. They're not doing what they should be doing. But you have to be prepared not to have that reaction. You have to be prepared to step back and think, well, why are they working the way they're working? Was I wrong in the assumptions I was making about how they would use my API? If so, how can I redesign it so we support what they're doing? It's a great way to get feedback. You have to be prepared not to be defensive and to take as much advantage of that as you possibly can. The amount of work involved in setting up the study is your usability engineer team will do that. They should prepare the tasks. They should recruit participants for you. So don't be put off by thinking that there's an awful lot of preparation work involved. Your usability team should be able to help you out with that. You should attend as many sessions as you possibly can. You'll get that benefit from watching people work. The usability engineer will take that data and work with you and analyze the data and present you with a collection with the feedback from that study to suggest here's where the API is in terms of the framework. You're at this point in abstraction level, you're at this point in learning style. Here's the comparison between the API and between what users want. And from that, you'll get a good idea about what we can do to then reiterate on the design and fix the problems that were observed. And you should repeat this process. Don't just do it once. Or at the very least, do it once. But really try and get feedback as often as you can. You'll get feedback to say, we made a mistake here. We need to implement something else. Then get feedback on that once you've made those changes. Make sure you're doing the right thing continuously throughout the project. So I'm just going to finish off with some common usability problems that we have observed over the last couple of years of doing usability studies on APIs. To begin with, there's some really simple things where names aren't chosen that map onto precisely what the actual object that the name is attached to describe what that object actually does. And this spans not just the names of classes, but the names of methods that those classes expose, the names of properties that those classes expose, even so far as the names of parameters within an API. We've had problems in the labs before where people have had to call one method. I think they were working with an API that required them to create a relationship, and they had to supply a source and a target for that relationship. And it was a relationship that represented an employer-employee relationship. The method they called simply had two parameters called employer and employee. There was nothing in there to indicate what was the source of the relationship and what was the target. The person in the lab immediately assumed, well, it's an employment relationship. The employer employs an employee. So the employer should be the source, the employee should be the target. But in actual fact, it was the exact opposite way around. The employee was the source of that and had the employer as the target of that relationship. There was nothing in the parameter names that represented that. It just said employer, employee. If the parameter name had simply been target, employee, source, employer, I beg your pardon, target, employer, source, employee, then it would have made much more sense to the participant in that lab. There's also a problem with lack of expressive types. Many APIs, if they're asking for many APIs will perhaps use Boolean parameters. Should we show UI or not? If we're doing some sort of operation, some copy operation, should we show the copy, that we copy UI or shouldn't we? Should we do this or should we not do that? Should we overwrite this file or should we not? When you're reading code that has Boolean parameters, all you see is copy file, source, destination, true. It's hard to know what that true means. Does that mean overwrite or doesn't it? How do I know? I have to go to the documentation to figure it out. Perhaps using an enum there might be more expressive. We see implementation-centric APIs versus task-centric. Another API that worked on on databases required that we ask people to write some code that performs a query against the database. But the only way they could perform a query on the database was if they called some method called getNavigator. Navigator was the object that represented the results of a query. They were looking for something like doQuery. But instead, they had to call something called getNavigator, which was the object that represented the results of their query. We have things where there's poor domain correspondence, where the objects that are represented in the API don't map well into the objects that people expect to see. We've seen things with the factory design pattern, particularly for those developers that I talked about earlier who like to explore a type and understand what they're doing. They can stumble with anything that requires them to use a factory to create an instance of some other type, because they know they want to create an instance of this type, let's say of type foo. They don't know they have to use foo factory to create it. So they start exploring on foo. There's no way they can create an instance of it, but they're not aware that they have to use foo factory. And that can be a stumbling block for many type of developers. Lack of consistency can cause problems where one thing works one way in some part of the API, it works differently in another API. Different names used for the same thing. Unclear dependencies between components. It's not clear that when you set a parameter or a property in one class, that has an effect on some other class. And an over-reliance on documentation. Many times people say after a usability study is, oh, well, we'll just fix the docs. Once we look at that up in the docs, that'll be fine. In that case, you're just using the documentation as a crux for poor design. You should document a well-designed API, not use documentation to paper over the cracks in your badly designed API. So I think that's about it for API usability. Any questions before we move on? All right, thanks very much.